good evening, whatever the case may be. The Sine Function Part 3. Elephant, Tame Impala from Dave's Faves, produced by the great Darby Foster. Let's finish this up, shall we? Let's do it. All right. So I mentioned I have one more complicated graph I want to do. We have learned about the amplitude affected by A, the period affected by B, horizontal translation is C, and vertical translation is D. So, one big happy family here. The principal axis, as we saw, is always y equals d, whatever that constant is, because it's going to move everything up and down. The period of the general sine function is 2 pi over b. We did that. And the amplitude is modulus or absolute value of a. So let's put all that to good use here. Now we got a monster here. Y equals 2 times the sine of 3 times the quantity x minus pi over 4 plus 1. There's a whole lot going on here. I've got an amplitude. If I start, well, let me back up. We're going to start with sine x and then try and sketch using all these things we know. But hopefully we're going to be able to skip a couple of steps because we're very smart. Very smart. Aight. So, we know that our amplitude is equal to the absolute value of 2, which is 2. Our period is equal to 2 pi over b, which in this case is 2 pi over 3. And our horizontal translation is going to be pi over 4 units right, and that for this right here, and then 1 unit up. Okay, so let's get to it. I'm going to go ahead and say that this is 1 and this is -1. So let's think about this. We got a whole lot to do. 2 sine x, okay, so I'll make this 2, and -2. If you watch my pen, that's going to look like this, right? Something like that. I know that. I can sketch that with no problem at all. So let me do it just real quick. So that would be like that. Okay, so that's one cycle, one period, 0 to 2 pi. So that's 2 sine x. But I've got this whole period thing, okay? The period is 2 pi over 3. That means that this cycle is going to repeat every 2 pi over 3 units. So it's going to squash up, okay? We're going to see this shape every 2 pi over 3 units. Let's think about that. I have my unit circle up here. If I were able to snip this circle from 0 to 2 pi, just make a little cut and lay it out, it would be the exact same length along the x-axis. This is not to scale, but I think you understand what I mean. So I can use that to understand how often it's going to repeat. 2 pi over 3 is located right here just after pi over 2. Okay, so here's pi over 2, and if you can imagine these divided into thirds, this would be pi over 6. This is right here would be 2 pi over 6, which is pi over 3. So that means 2 pi over 3 is about right there. Okay, so that means this critical point, all my critical points are going to move to the right 2 pi over 3 units. Okay, so that's about here, and then this one would move about here. And then this one would move about here. Okay, so I have this situation. So with the period of 2 pi over 3, if we think about that, just past pi over 2, so if you think of this as pi over 6 about here, pi over 3, that puts 2 pi over 3 about right here. Meaning this curve right here is going to be shrunk into this little space. Well, let's look at this cycle. Halfway between the beginning and the end, I have a 0. So I'm going to mark that. Remember, we're sketching, so we don't have to be perfect. And then halfway between the zeros, we have a max. Well, halfway between here and here is about here, so that's going to be like that. And halfway between the second two zeros, it's going to go like, it's going to be a minimum, sorry, and that's going to be about here. So now we have a situation where we have one period looking like that, okay? And I'm going to get rid of the sine curve now, the original sine of 2x, because it's just in the way and things are going to get dicey here, okay? But I need to sketch this. They didn't say it, but we're going to sketch it from 0 to 2 pi, okay? Well, 2 pi over 3, another pi over 3 is this, and then another pi over 3 is this. So that if I go 2 pi over 3, another 2 pi over 3, and then another 2 pi over 3, I get to 2 pi. In other words, there's going to be 3 cycles. 3 cycles of this, man. Okay? So where's my next endpoint? My next endpoint is 2 pi over 3, 3 pi over 3 at 4 pi over 3, which is just before 3 pi over 2, or it's pi over 6 units away. So it's about there, and using that, I can eyeball my maxes and my mins again. Okay, so I've got this. Again, my period is 2 pi over 3, my amplitude is 2. And then I know my endpoint is 2 pi. Halfway through, I've got a 0. Halfway here, I got a max, and halfway here, I got a min. So now I have sketched the curve of y equals sine of, two sines, sorry, of 3x. Okay. Well, now all I have left is a horizontal shift of 4 and a vertical shift of 1. And I suggest we do that all at once, and I'm going to do it in blue. Now remember, pi over 4 units, here's 0, here's pi over 2. So just one of these little boxes is pi over 4 units. So this is going to move. This point right here moves pi over 4 units. This moves pi over 4 units. This is just past here, maybe here. Remember, we're just trying to use this length right here as a guide. Maybe here, here, just before here, moving everything pi over 4 to the right, about here, about here, about here, about here. And then I have to move them all up 1. Oh my goodness, up 1 unit. So bam, maybe I should put X's now. Actually, I'm going to go red so I don't get confused. So I'm moving this up 1 unit, so that's here. This goes up 1, I got to go off the board about here. This goes up 1, about here. Down here, this goes up 1 to about here. This goes up 1 to about here. Let me start sketching, man. So I've got this right here. And then that blue one goes about here. So that's 1 cycle. And then, let's see, we move up 1 here. We move up 1 here. Go down to my min, up 1, back up again. So we got another cycle in there. Boy, oh boy, this is a little difficult. Then up, we did that one. So this is going to go up here. This is going to go up here. And then we can kind of eyeball it that it's going to start going down. And then it's going to go out of bounds there. This one, the same thing. You can see how the shape is just going to go to about, it's going to start going there, and we're about done. So that's what it looks like, or that's just a sketch. That is kind of difficult, but you should know how to do that. And now I'm going to go through that process just with the graphing calculator. So my graph is going from 0 to 2 pi. Vertically, each of these are worth 1. It goes all the way from 4 to -4. And these are pi over 4 units. So this is pi over 4, pi over 2, 3 pi over 4, and pi. okay, because we're going to shift pi, and I just wanted you to be able to see it. So let's just start with 2 sine x, see what that looks like. 2 sine x, as we would expect, okay, amplitude of 2, period of 2. Now I'm going to change that to just the 3x, and this is where it gets funky, where the period goes from 2 pi to 2 pi over 3, remember? So let's see, there's going to be a 3 there, bam. Okay, so let's take a look at that. Instead of going the full cycle, let's go ahead and put sine x in there just for kicks. Okay, oops, that should be 2 sine x, sorry. Okay, and you can see how sine x compressed into 1, 2, 3 cycles. Okay, that's because the period changed. It repeated itself every 2 pi over 3 units this time. Okay, so let's get rid of that. Okay, so then what happened? Well, from this is where we moved to the right pi over 4 units and up 1. So I'm going to go ahead and just graph that one. I'm going to leave this on here. So it's this shape. Just imagine it going to the right pi over 4 units and then up 1 unit. Okay, so we have 2 sine 3 x minus pi over 4 and then plus 1. Now let's see the shift first. Let's just see a shift of pi over 4 units to the right. Okay, so let's get this out of the way. That means from the maximum right here to the maximum right here, that's a shift of pi over 4 units, which looks good because from here to here is pi over 4 units. This distance between the grid marks is pi over 4. And now let's lift that up one to just do the vertical shift, and our graph looks like that. Okay, so we didn't do too horribly. We'll be utilizing our graphing calculator quite a bit. And that's all I wanted to show you. So that's the end of graphing the sine curve. I certainly hope you enjoyed it. I know that I did. And let's end with the elephant, Tame Impala. And with that, I am out!